All right, hello everybody. So this is going to be our first installment of engine components, um, how the different components work in the engine and what their jobs are. Um, Many of the parts have multiple jobs within the engine because it's so compact. Um, and in order to just be as efficient as possible, they all have multiple roles, and we want to be aware of what those roles are so that we have a good understanding of how the engine works, and more in particular, when we have problems with the engine, if we can identify what the problem is and we know the parts that are part of that system, then we can kind of start to isolate which part may be causing the specific problem that we're seeing. Okay. So as you begin to disassemble your engine, one of the first parts you're going to be taking off is the pull starter. Okay, it typically is part of a cover that looks like this. All right, and it has the little pull cord on it. Okay, that we use to start a lot of the engines. Some are electric start, but a lot of the small ones are pull start. And basically, right, we have a cord that we can pull here that's spring loaded. Okay. In the bottom of that is what we call a rewind starter. Okay. If I pull it out really quickly, what you will see, and you can see in the picture here, is that there are some small paws that come out, okay, or like little gripping arms. And what they do, these are also kind of spring loaded. So when I pull fast enough, these things pop out. And what they will do is engage this piece here called the starter clutch. This is like a metal cup. Sometimes they're part of the whole flywheel piece, but a lot of times they are separate. So you might have one of those two different styles. And basically, as this engages the cup here, it's going to turn the flywheel, which is actually going to then turn the internal parts of the engine. And this is key to getting the engine started. We got to get it moving. And basically, what you are doing is by hand, you are creating the first couple of cycles, okay, getting fuel to be intaken and creating a spark so we can actually start the engine. And once that happens, then the cycle will kind of continue on its own, okay? So another job of this general piece here is also just to keep the flywheel covered. The flywheel is moving very fast, and we wouldn't want for our hand or any other thing to get caught in there. It very quickly would grab onto any kind of a cord or string and suck it right in, and that can be very dangerous. Okay, it also will cover up some other electrical parts, and again, we would want to make sure that we can't accidentally get shocked as the engine's running. And so, that's kind of the dual role of the coil starter. So the inside of the coil starter actually looks like this. So you can see what we have in there usually is a coil spring. And so there's a big piece of metal that's wound up really, really tight. You'll find it either under or inside of the little pull starter piece that you can see here where the cord wraps around. You do not want to take the spring out unless it's broken. Once they come out, they're very, very hard to get back in. You have to wind them up really tight and hold them wound and kind of place it into the center area here. There's some hooks on the side. That is a whole lesson in itself, how to get those in. It's a big, big pain. Okay, so you should be aware that that's what it is. And if all of a sudden your pull cord is not either going back in or you feel no resistance when it comes out and it stays out, then you probably have a coil spring that's either broken or has come off of its holding areas. Okay. All right, so the flywheel itself is a very important part to the engine. You can see we've got a couple of things going on here. We've got some fins typically around the flywheel. On some of them, they are going to be metal and part of the flywheel. On other ones, you might have had a little plastic piece that sat on top with some different fins. Okay. And in order to take this off, you will probably need a combination of a flywheel holder, which is kind of like that metal flat metal shaped piece, and it's going to hold on to the small little areas here, the little curved areas there, and hold the flywheel steady. And then you're going to need to get a large wrench or an impact gun and take off the nut here. They're usually on there very, very tight, and so you're going to need some good force to get that off. Okay, my at-home folks, hopefully I've loosened that for you, and you're able to get that off without any problems. Okay. So some things that these fins do, they provide some cooling for the engine. Most of these small engines are air-cooled, meaning that they don't have some kind of coolant system like your car might. So we're just really pulling in fresh air to keep the engine as cool as possible so things don't overheat and start to break. Let's see here. Another major role of the flywheel is just to keep momentum. The flywheel, even though it's made of aluminum, has some heavy parts to it. And, if we think about our engine cycles, there's only one cycle, the power cycle, where we're actually making power. In the other cycles, the engine is kind of using whatever was left over from the power cycle to push it through its movements, okay? And so the flywheel, the way it kind of works is that it's just heavy. It takes a lot of energy to get it going, but once we get it going, it takes a lot of energy to slow it back down. So flywheels were actually one of the first mechanical type of tools that humans used, way back in the industrial revolution. Some history there for you. If you think back to like a water wheel or a mill, you might have learned in history where we would use a waterfall or something like that to turn the wheel. Well, that wheel is a great example of a flywheel. It's really hard to get going, but it's super heavy. And once it starts moving, the momentum from that will carry on for quite a while, and it doesn't take as much effort to keep it going. So the same thing is true with our flywheel here, even though it's a couple hundred years later. Okay. So another thing that's hard to see from the picture here, you can kind of see it sneaking around in the corner, is that the flywheel also has a magnet on it. And we're using this magnet to create electrical energy for the spark. Okay, and we need that for the power cycle. So you'll find the magnet on one specific side of the flywheel. And essentially what's happening is as the flywheel is turning around and around, it's going to be passing a horseshoe-shaped piece. Sorry, I'm trying to find the camera here. It's actually another magnet. And when we pass those two magnets by each other really fast, what happens is we actually are generating electrical current. Okay, the spacing between those parts is very important, and we need some clean surfaces for those to work well. But essentially, that's what's happening. We're moving a magnet by another one really, really fast. And when we do that, it actually creates an electrical flow. And then that goes to the spark plug, and the spark plug actually creates the spark inside the engine. Okay. So a couple other pictures here I want to show as well. So it is possible that you had a different type of flywheel nut on the outside. This is actually called a starter clutch. And it works the same way as the coil starter does, in the sense that we have a pull cord, and it's going to engage this big metal piece up top here. But the lower half here is actually acts as the nut, and this is actually threaded right onto the end of the crankshaft. You need a specialty tool to take this off, so hopefully no one at home has this one. I don't believe you do. But you would need a tool that hooks onto these two outer edges. It's kind of a funny looking wrench to take this off. And the inside of this device kind of looks like this. We have some ball bearings, okay? And you can see we kind of have some wave-shaped pieces here. So basically what happens is when we pull the pull cord in one direction, this thing is going to turn. It's going to engage these ball bearings, and it's going to turn this whole setup. It's going to turn the flywheel and everything. Now, when the flywheel starts moving faster, the engine starts, then the ball bearings are actually going to go to the outside and hide up in these little pockets, and they're going to basically the inside piece is going to no longer be engaged. So it's going to be allowed to spin freely, kind of like the back wheel on your bike. So if you've ever ridden a bike, right, with like a 10-speed or something like that, or a mountain bike where you can pedal and it will engage the gears, but as soon as you stop pedaling, that wheel is still allowed to spin freely, okay? And that's because you have some kind of device like this in here, same way kind of like a socket or a ratchet wrench works as well, where it'll engage in one direction, but in the other direction it won't, or like with the bike wheel, it'll engage when we are pedaling faster than the wheel is going, but if the wheel is going faster than us, then it's allowed to spin freely. Right? Otherwise, it would force the pedals to keep moving, okay, even when you didn't want to pedal, which if you were going down a hill really fast would be really hard. The pedals would be flying. Some old bikes used to kind of be like that. Okay, so that's a good overview of these two parts here. I'm going to stop the video at this point so we can move on to the next one.